in this example, we're going to take everything a step further. So we are going to utilize some of our previous concepts, and then we're also going to start being able to compute the least squares line by hand and also checking it, and then utilizing the least squares line. So we have some data below that shows the relationship between a car dealership, how many hours that their salespeople work per week, and then the number of, or the amount of profit. And the profit is in tens of thousands of dollars. So for example, this isn't really 45, this is 45,000. All right, so just keep that in mind. But instead of typing 45,000 in, just for simplicity, we'll keep it like that. So we want to do a number of different sorts of things, some from section 4, some from section 5. And the first thing we want to do is we want to be able to identify the explanatory variable as well as the response variable. So we should be able to predict the profit based on the number of hours. So the explanatory variable is going to be the hours worked. And then the response is going to be the profit. So we should be able to predict the profit based on the number of hours worked. The next thing we need to do is construct a scatter plot, which should be pretty easy because we're really good at scatter plots by now. So this is part B. So we're going to have our hours worked, and we should start at 200, go in increments of 50. It's almost like somebody set this up really nicely for you. So this is 200, 250, 300, and 350. And the profit, we start at 45 and we go up to 131. So let's just start at 0. And I'm just going to call this 0. And let's just go in increments of 50 to make it really nice and easy for us. We're going to label our axes. So these are hours worked. And then this is our profit in thousands. So I just abbreviated thousands just for simplicity here. Right, and then we're just going to plot this. So we have hours worked is 245, so maybe like right about here. And we're hoping for a linear association because we're just trying to ensure that the data is linear. 250, 73, which would be right about here. And then 300, 108. Maybe right here. So we have a nice linear association so far. And then 350 and 131, which might be about here. All right, so if I were to characterize this scatter plot, and we only have 4 observations, we would say it's strong, we would say it's positive, and undoubtedly, the most important part is that it's linear. All right, so that's good news because that means we can go on. That's bad news because it means we have to go on. So the next thing we're going to do is we're going to find all 5 of the variables, excuse me, that we looked at before. So we're going to use our calculator and we're going to clear out this. We're going to go to stat. We're going to go to edit. We're going to clear out both of the lists. So we're going to go up, clear, enter. And we're going to go to L1, clear, enter. And remember our data was 200 and then 250 and then 300 and then 350. Which was nice and easy. And then I think we had 43, maybe. I can't remember if it was 42 or 43. It was 45. And then 73. And then 108 and 131. All right. And just like we did before, remember we have to go to 2var stat. So we're going to go stat, we're going to go calc, we're going to go 2var stats. And so we have our X bar and our SX. All right, so we get 275 and 64.55. So this is part C. So X bar, we have 275. And then SX, we have 64.55. And then we need Y bar, and then we need SY. All right, and remember to get those, you go back to the calculator, and you just scroll down a little bit, So y bar 89.25, sy 37.933. So 89.25, and then y bar was 37.933. And this should be 89.25, not 8.925. Right. And then finally, the last thing we're going to do is we're going to find R. All right. Now, R should be positive, and it should be close to 1, right? Because it's strong positive linear. It should be close to positive 1, as it's almost a perfect association, almost like somebody made up the numbers. So we do this, and we're going to go stat, we're going to go calc, and then remember we go to lin reg ax plus b. And we're going to enter a few times, and we get that R is 0.997. So it's almost a perfect association. Like we said, it's like somebody made up the numbers for us. So R is positive 0.997. All right. So we've gone through the old stuff that we know. All right. So all three of these things were things that we've done in the past. But the good news is we've characterized it, and we know that we're going to get a good equation out of this. So now what we're going to do is we're going to compute the equation of least squares line using the built-in calculator functions, and then we're also going to use the formulas. All right. So for part D, that's easy because remember, all we need is A, which is B1, and we need B, which is B0 from the calculator, and then we could build the equation of least squares line. And so A is 0.586, and then B is negative 71.9. Notice that there's not a lot of runoff here, and that's probably because R is so close to being perfect that the calculator just truncates all the zeros that are after that. All right, so negative 71.9 and 0.586. All right. And so finally, we just go through. Remember that we have y hat equals b1x plus b0 is our formula. And so we already know what b1 and b0 are. So y hat is going to be equal to 0.586x plus a negative 71.9, or another way to write that, we could just write it as minus 71.9. And in math, we try to use as few symbols as possible. All right, so that's our equation of our line. Now, what if we computed that by hand? All right, and remember our formulas. All right, so now we still have y hat equals b1x plus b0. Okay, that's easy because we just found it. But by hand, we remember that b1 has a formula. And what is the formula for b1? Well, we go all the way back up, and we recall that b1 was this. Right? So we have R times sy over sx, and then b0 is this formula. All right, so those are two important formulas that you want to have handy, especially for an examination or quiz. So remember, b1 is going to be R sy over sx, and b0 is y bar minus the quantity of b1 times x bar. Right? But the good news is we already know all those variables. Okay, they're right up here. So I'm going to copy these so that way we have them, and I'll erase them when we're done. There we go, technology. All right, so let's just find b1 first. So b1 is going to be equal to this formula, which is going to be our 0.997 times sy. So we're using these three computations. So that's 37.933, and then we're dividing that by 64.55, and that should give us what R is. So we're going to compute that in our calculator. So we're just going to go to the main screen, and we're going to do 0.997 times parenthesis. We had 37.933, and we're going to divide that by 64.55. I can't remember. 55. All right, now we end up with this 0.586 if we were to round to 3 decimal places. All right, so 0.586 is our A, or our B1, excuse me. So this is roughly 0.586, I think it was. I forgot already. All right, so we're going to hold on to this because this is B1, and we need that. Now, B0 is going to be this formula right here. So we're going to use Y bar, we're going to use X bar, and then we're also going to use this value that we just got in the previous step. Right? So Y bar is 89.25 minus the quantity of B1. All right, so we're using this formula up here. So we just use Y bar. B1 is 0.586. And we're going to multiply that by X bar, which we just found to be 275. So we're going to just shove that in our calculators. And we're going to get 89.25 minus the quantity of 0.586 times 275. And we end up with negative 71.9. All right, now, our least squares equation, if we just put everything together, remember we have that y hat is b1x plus b0, so y hat is going to be equal to 0.586x, which is right here, minus the 71.9. And I wonder if this looks familiar. So we have 0.586 and negative 71.9. Remember what we did in the calculator? 0.586, negative 71.9. All right, now, this isn't coincidence, okay? We either got extremely lucky or the formula works, and obviously the formula works. Now, I want you to notice that this doesn't always happen to give us the exact same answers. The reason the answers were almost exactly the same was because R was almost perfect. The closer R is to 0, the more disparity there's going to be between the calculator's value versus what you have. All right, so just be aware of that as you go along with this, okay? So it's just something to do with the reliability. In this case, it's really nice. Okay. So there's a few more things that we have to do. So I'm going to copy and paste those, but these are the easier parts of the problems because it's just using this. Okay. And so I'll copy this, and it doesn't really matter too much about that close to 1 that's kind of lumped in there. And I'm going to paste that right here because, all right. And we just computed part E, I think it was. So now we're on actually F, and I know it says something different, but this is actually part F that we're going to be doing. So this is F, G, H, I. We know that Word likes to keep things in order. So use the equation least squares line to predict the profit if the number of hours worked is 180. All right? So 180 is the hours worked. And remember, hours worked in the original problem was the X variable. Okay, so if we go all the way back up, remember we had hours worked on the X axis. And then on the profit, that was on the Y axis. Or in this case, it's going to be Y hat. Y hat meaning Y predicted. Okay, so down here, all we're going to do is we're just going to substitute X equals 180. And so we're going to get that Y hat is going to be equal to 0.586 times 180 minus 71.9. And if we go through and compute that in our calculators, so we get 0.586 times 180 minus 71.9. That gives us 3358. So that gives us 33.58, or in other words, remember that's in thousands, So that's going to be $33,580. And again, that's just because it is in thousands. So since the question does ask us specifically to predict the profit, we want to make sure it's in a dollar amount. Right? Now, the question that lies in thereafter is, do we have an extrapolation or do we have an interpolation, and why? All right, so what we're going to do is we're going to look at the x value, which is 180, and then we're going to go all the way up to the original data. So the original data, notice that 180 is outside of the original data set, right? Meaning that it doesn't fall between two numbers. So what we're going to say is that this is an extrapolation and the reason we could say is since x equals 180 does not fall between two x values in the original data. All right, so that's pretty easy. Okay, we just go up there and we see whether or not x falls between the two numbers. All right. The last part says we're going to use the equation of least squares line to predict the hours worked if the profit for that week was $100,000. All right, now we have that y hat, which is, remember, y hat is the profit, right? And we're going to go back and we're going to say y hat is equal to 100,000. And remember, we can't use 100,000 in our formula, okay? So what we're going to do is we're going to replace that, and we're going to say y hat is equal to, remember, because this is in thousands, is equal to 100. And that's what we're going to use in our formula when we go to compute, all right? And again, that's because it's in thousands. So we have to go the other way, and we have to put it back into just regular form, all right, regular for us. Now, remember we had the formula that y hat equals 0.586x minus 71.9. So in this instance, what we're going to have to do is we're going to have to do some algebra to be able to figure out what x is. All right, so we're going to substitute 100. So we're going to substitute 100 is going to be equal to 0.586x minus 71.9. And our job is to be able to solve this for x. Right? And to solve for x, we're going to have to first add 71.9 to both sides. So remember, all the way back from Algebra 1, you just add first. Now those cancel out. 171.9 is 171.9 equals 0.586x. And then to get rid of the coefficient 0.586, we're going to divide by 0.586. And that one we're going to do in the calculator to solve for x. So x, we're going to take 171.9. And we're going to divide that by 0.586. Let me just make sure I copy the numbers down. Yep. And we end up with 293.345. So that's going to be 293.345. And that's in hours, right? Because remember, x represents the number of hours that it takes to be able to get that profit. Right. Now, the last part of this asks, is this an interpolation or is this an extrapolation? All right. So once again, we go back up and part I says interpolation or extrapolation of y. And this is going to be dependent upon whether 293 falls between two other x values. So let's go all the way back up to the original data. And we're almost done with this. This is the easy part. So all the way back up here. Now clearly 293 is between 250 and 300. So 293.345. It is between. So since it's between two values, that means we're going to have an interpolation this time. Right? So this is an interpolation. And the reason it's interpolation is because x equals 293.345 falls between two original x values in the data set. And I'll put in parentheses, those would be 250 and x equals 300, just to be specific. All right, so that way there's no doubt. All right, so hopefully this gives you an illustration of how we can utilize the least squares line and also how to formulate the least squares line, both using the calculator and using the formulas. In the next video, we're going to interpret what the error might look like for this.